So, very good afternoon. So, welcome to Let's Crack CBSE Science and welcome to my class. So, I hope I am visible and audible. We'll just wait for 1 or 2 minutes and then we'll pitch in. So, I hope it's clear from the title that what we'll be discussing for the day. As we have been dealing with CBSE Class 12 Computer Science, and we have been looking into each of the different portions that you need to learn as per the syllabus. And we started off with Python, and then we had classes running from covering details on the basics of the language Python, and then we had data structures. We learned about files in Python and its implementation, though we had not completed. I think a few more topics to be yet covered, plus the question discussion is pending. Um, Today we'll be discussing on computer networks. So almost all the majority topics that that is coming under computer networks. I am hoping to complete it over today's class. So yes, this is a marathon session. So let's pitch in. I hope I have an access to the keyboard. Yes. Yes. So good afternoon. Welcome to Let's Crack CBSE Science and welcome to my class. So before moving on to the detailed description on Unacademy and the agenda of the day, let me give you a brief introduction about myself. Hello, I'm Shalini. I am a BTech and MTech holder in computer science and engineering. I am a teacher by profession with over 14 years of teaching experience. With Unacademy, I'm excited to provide an inspiring learning experience to all the students via this online platform, so whom I could not have reached otherwise through my offline or classroom teaching. Yes, Sandeep, I'm fine. I hope you are safe, sound, and healthy too. So, as the title suggests, today we'll be looking into the topic of computer networks. Okay, so as you all know, Unacademy has grown out to be India's largest e-learning platform. So it is not just because of the reason of the pandemic situation, but also for the reason that Unacademy gives courses or it has courses running from for a school-going student, ranging from a sixth grade student to a person or an aspirant who's preparing for a competitive examination. So it is like a one-stop destination and it is the most happening app of the day. So thus it has grown to be the India's largest learning platform. So To get access to the resources of Unacademy, resources in the sense the live and the recorded classes, live and recorded classes from India's best educators. All you need to do is get a plus subscription from Unacademy. The details on the subscription and the subscription fee would be are coming in the coming slides. Yes, Sandeep. We are planning to complete computer networks, the topic on computer networks, though you have some theoretical concept in this chapter. Okay, it is completely different from the language topic that you will be learning. You will be learning on networking and the concepts on networking here. Okay. So, introducing the new iconic subscription. Now, this would help your CBSE preparation if you are a CBSE student to the next level. Now, how are you getting escalated to the next level? Is with the help of a personal mentor. So once you get an iconic subscription, uh, you get a personal mentor wherein you get one-to-one guidance from the top experts as your personal mentor. Okay, so this would help in aligning a learning strategy and resolves all your personal concerns with regards to your studies. Okay, now you have a parent connect wherein you have regular open hours for the parents. Okay, parents of the ward, so he or she can discuss with the mentor, corresponding mentor, about the ward's performance and receive a weekly performance report. Okay. Apart from that, there is a live doubt solution. So, exclusive doubt solving classes to solve these subject doubts and get a customized study plan. Okay. So, this would help you to track your progress. Now, all these features plus the features of plus or all the benefits of plus subscription also. So, the subscription starts from the range of 2,333 per month. Okay. So these are the details with respect to plus subscription. I hope it is familiar to all of you. In the plus subscription, you get access to the daily live classes wherein you get an opportunity to chat with the educator, engage in discussions, ask your doubts and answer via polls. Now, all the facilities while the live class is going on. Now, herein, this educator wouldn't be concentrating just on a single person, but to a class on a whole. Okay. So, if you want a personalized attention, you should go for the iconic subscription, and in the plus subscription, these are the features available here. So, you have daily live classes. Now, all the courses here are well structured and in line with the exam syllabus. Okay, now there are live tests and quizzes. This would help to evaluate your preparation and also gives you an analysis of how well you're performing, or gives you an analysis of your performance and gives you a confidence for the forthcoming examination. Now, how to get access to all the resources? Now, all the above mentioned resources, the solution is getting a subscription. Now, once you get a subscription, you get access to all the live as well as recorded courses. Now, since the live and recorded courses, you get access, this can be viewed at the comfort of your time as well as the comfort of your devices. So you needn't worry if you miss out a daily live session, because you get an once you have a subscription, you can get to view the recorded version of the same. Okay. Now, these are how the live classes would look like. You would have the live button in it, and this is how a recorded class would look like, or which is coming. Which is proposed to be coming later on, or any recorded classes would not have the live button on it, and you also get intimations in your smartphones when a live session of your goal is going on. So here is a reminder session also. Okay. So here, when you see the live classes, now what you can scroll in to see which are the live classes, which are the upcoming classes, and also the recorded versions of the classes. Okay. Now, this is how the comprehensive syllabus would look like. You would have the different subjects, and underneath each of the subjects, you would have the courses listed. So, which can be viewed based on your taste and requirement. Okay, now, so this is how the comprehensive syllabus would look like. For a school going student, you would have the subjects and all the courses running underneath. Each of the subject would be listed beneath, which are offered from the best educators all over India. Now, this is the Unacademy learning app that you need to download from the Play Store and install in your smartphones. Okay, and then you can get a subscription based on your choice. Fine. So I repeat, it is the Unacademy learning app that you need to download in your smartphones. Now, here are the different steps via which you can download it. What you need to do is you need to type in at the search bar the Unacademy learning app. Okay, and this is the icon with respect to the Unacademy learning app. And once you see that in the Play Store, what you have to press the install button. Okay, now this is the second step. Okay, now after that, based on this, you need to, I mean, these are the different steps for it. I mean, you can manage goals. Now, in the manage goals, you would have all the current running courses being listed below. So, from this, you can choose the class or the section that you need to attend to. Okay, suppose you here they have shown with respect to CBSE class 9. Now, if you're choosing the CBSE class 12th, and then this is in the last step, you would get the different the modes in which you need to view the classes or in the app, wherein you can take the plus subscription and then go on. You can step in or you can pitch in to see all the free courses as well as the special classes. Now, all these special classes would be unveiled once you get a subscription to the Unacademy. Okay. Now, apart from that, there is a section for the free courses also. Now, apart from all these, there is a Telegram app or a channel too. Now, to get access to the channel, you need to download the Telegram app and see the URL that is being listed here. So what you need to do is you need to type the link in the URL as shown in the figure and click to join in the channel. Now, when you get updates about the postings from Unacademy as well as the posting from various educators. Okay. Now, here is the detailed description on the fee with respect to the plus as well as the iconic subscription. Now, this is the detailed fee with respect to the plus subscription, and here we have the detailed fee with respect to the iconic subscription. Okay. Now, we see here the different plans listed, and across each of the plan is listed the cost or the subscription fee, ranging from a month subscription to a 2-year subscription. Okay, so a month subscription ranging from 2,700 to a 2-year subscription ranging around 22,500. Okay, now if you apply my promo code SLYT, now apart from the benefits that is being shown in the table, you get an attractive 10% off on the subscription fee. Okay, so I repeat, if you apply my promo code SLYT, you get a 10% discount on the fee that is being listed here. Now the same goes with iconic subscription also. Now the benefits of the iconic subscription was already told. Fine. Now these are the different plans with respect to the iconic subscription. Okay. Now ranging from 6 months to a 24-month plan, and the cost for the plans are also being listed here. On applying the promo code, again you get a discount of 10% on the fee subscription. Okay. Yes, moving to the agenda of the day. As you all know, we have been dealing with the CBSE Class 12th Computer Science, and today we are looking into a very important topic, which is the networking, or in short, the computer networks as per the NCERT syllabus. Okay, so welcome all of you to the class. And these are the contents that we'll be covering in today's class. We'll have a brief introduction on the topic of what computer networks are. We would look into what are the different advantages and disadvantages of computer networks. Then we'll be looking into the different components of a computer network. We will also see the different types of networks and the various network devices. Now, apart from that, we will have a small definition with respect to cloud as well as IoT to just mark the end of today's class. Okay, so moving on. So, introduction. Now, as per the introduction, a computer network is a collection of interconnected autonomous computing devices so as to exchange information or share resources. Yes, Ritanshu, very good afternoon and welcome to my class. Okay, so as per the definition, a computer network is a collection of interconnected autonomous computing device. Okay, so it is a collection of device. Okay, fine. Since it is a computer network, well, it will be having a collection of computers. They are interconnected. So that means no system or no device here is a standalone, and they are being connected to each other by one or the other way, and then they are autonomous computing devices. So that means no computer here has a control. No device can stop, start, or control because the other device, because everyone is working as an autonomous, or as it is enjoying the features of a standalone system, but still it is getting connected with each other. Now, what is the main purpose of creating a computer network? This is to exchange the information or share resources. So whenever we talk about connectivity, the main aim of connectivity is exchanging information as well as the sharing of resources. Now, prior to going into computer network, let us see the network that we are familiar with. Okay, say for example, our friend circle. Okay, or any circle of contacts that you know, right? So if you take your WhatsApp, for example, you get a link of, you get the everyone who is in your contact list in the phone would naturally be appearing in your WhatsApp, right? So you are in some or the other way in connected with all the contact list in your phone, in your personalized phone. Now, in this case, you can call this as a human network. Fine, you have a network of friends. Okay, if not human network, you can call it as a network of friends. Now, wherein is the network of friends required? You require this network of friends to, for your connectivity, for your livelihood, as well as for many other necessities. Suppose you want to know something, or if you want to know the price of something, or about a course that is happening somewhere, or about a school that is being performing somewhere, or about what are the courses being offered in a school, or something like that. What do? You either check for the newspapers, you check for the website, you check with your friends to know the feedback, right? You go around asking people who have already learned or who are already using the same thing. Okay, now this is how you get a feedback, right? Now, based on the feedback is how you decide whether you want to go for it or not. Okay, so this is the importance of a friends network, right? So similarly, it happens with the computer network. Now, wherein a computer network, when we talk about a computer network, we are talking about a collection of devices wherein the devices are preferably computers, right? So what does the definition say? The definition says that it is a collection. Now, collection of what? Collection of computing devices. Now, how is a collection maintained? They are interconnected. So that means the computing devices are not standalone devices. Instead, they are connected with each other, or they are interconnected devices. Now, what else? See the next terminology. It says autonomous computing devices. Now, what do you mean by autonomous? Autonomous meaning that nobody is having a control over the other. Each of the device is an autonomous device. That means it's working. I mean, the start of the operation, the stop of the operation, and also the control is not being controlled by any other devices. It is working on its own. Okay. Now, to get involved in the network, it has to be connected. That is the only criteria. It has to be connected via some means with the devices. Fine. Now, why is a computer network needed? It is for the exchange of information as well as for sharing the resources. So, why do you go for a computer network? All you need to know is you are going to share the information. Just a minute. Okay, this is for exchanging of information as well as for sharing of resources. Now, example of the computing devices are, now all the computing devices means it can range from your smartphone. It is not just your system or your laptop, but ranging from your smartphones, laptops, smart TV, etc. Okay. So these are all the collection of computing devices. Now, in a home itself, you have a network wherein you use the internet or the Wi-Fi for your smartphones, for your laptop. If you have a desktop, then you have it. For all the members who have the smartphones, again they are using the same network. So, in some or the other way, these are all computing devices, and they are getting connected to one another. Is the idea clear? So, these are the examples of computing devices or smartphone. Okay, the examples are smartphone, laptop, smart TV, etc. So this goes with the definition of the terminology which is called as the computer network. I hope each of the term is clear here. Fine. The terms involve collection, the terms involve interconnection, collection, interconnection, autonomous, and computing devices. Now, these are the terminologies that come up when we talk about the definition of something called as the computing networks. Okay. Now, what exactly is the need for networks? Okay. Now, we understand that man is a social being, and definitely it is communication that helps man to interact with others. So, the computing device is also one sort of a device which would help the human being to communicate with one another, right? So in the case of networks, the primary concern is the communication and as well as resource sharing. Okay. So see here, when we take an example of right now Unacademy. Now Unacademy itself is a network of educators as well as learners, right? You have both learners as well as educators. So when I am taking a class, I get a network with a range of students. I mean, with a collection of students. Okay, need not be online but offline also. Because the same session is available as recorded versions also, wherein you can visit the classes as and when at the comfort of your time. Right. Now, what sort of a resource sharing? Now, what an academy or the platform does is it is enhancing or facilitating a resource sharing between the educators as well as the learners, right? Now, if you're taking each individual educator, now what the educator provides to the learners is the abundance of knowledge that he or she has with respect to a subject. So when we are talking about a computer network, naturally the same concept gets carried over here also. We give emphasis for enhancing of communication as well as we also talk about something called as resource sharing. Fine. So all the resources that you do not have with you can be taken or lent it from or is available to your system from another system. Is the idea clear? The next is reliability, because once you're getting connected with each other, you know that yes, this is a reliable source. You can get some or the other forms, or you can get an information in some or the alternative forms from the network in which you are connected to. Is the idea clear? So these are the requirements, or these are the points wherein we understood that yes, we need to go for something called as a network, and here exactly comes the necessity of a network. Now, this is not just with regards to a human network or a friend's network, but also with respect to the computer networks. Is the idea clear? So, the points that would be highlighted here are communication, reliability, as well as resource sharing. Now, reliability, when you rely on a friend, you rely on a friend when he or she turns up to you at both your good times as well as your bad times, right? So when you rely a system, you mean to say that you are relying on the system for accessing of information, for getting resources or sharing resources, or to facilitate something called as communication in your context, right? So when all the three terms come together, we identify that yes, there is a need for the networks. Fine. So let's move on to the next topic, wherein we would learn about the advantages of networks. So definitely when we are learning advantages, we need to see the disadvantages of the same topic also. Okay. So advantages of networks. It facilitates. Now there are certain things that it facilitates. We already saw that sharing of resources has to happen here, right? Then sharing of storage space. Now, do you think that whatever you do in your system is going to be stored in the primary memory or secondary memory of your device alone? No, you can have it stored elsewhere also. Fine. And you can also get access to the resources that are being stored elsewhere also. So hence, sharing of storage space as well as facilitating sharing of software. Now we talk about sharing of software when things are not centrally controlled, when there is a distributed environment, and wherein you get access for sharing of softwares also. Now definitely the most important part, wherein you get enhanced information by communication. Why? Because all the systems are connected to one another in some or the other way. Okay. Then you have a cost reduction. Okay. So definitely when you're trying to install all the things in a single system, definitely the cost incurred would be high, because your system have to be high end performing. Only then it can accommodate all the resources that you want. But instead, if you're having a sharing environment, or if you're having a network wherein you can get access to the resources from another system, in this case you are actually cutting the cost, right? Rather than dumping a single system or overloading a single system with the entire thing, you're actually distributing the workload by actually cutting the cost. Okay, fine. Then what is scalability? Scalability means you're either increasing a network in the number or decreasing in the number, right? Now, when you have a network of, now before going into the computing devices, let me just think about the network of your friends, right? On a daily basis, your friend network or your circle of friends naturally gets increased. Or do you cut down your friends, number of friends? No, right? You definitely, for as each day passes or in due course of time, you actually meet new people, you make new friendship. So definitely your friend circle or your friend network is going to increase, right? In the same way, when you're talking about computer networks, we talk about something called as scalability. So for each time a device can be added to the system, right? Or a device can also be removed from the system. Now, as I was talking about a common Wi-Fi system wherein you would have each of the devices in your system accessing this Wi-Fi, right? Now, imagine one of your friend is coming to your home. So naturally, he wants to access the internet. You would say, yes, you have Wi-Fi connectivity at your home. You would share the password. So definitely this friend is also accessing the Wi-Fi. Now what happens? Here, the number of devices which are already, using the internet now increases. The number of devices get scaled up again. Now, this friend is not going to stay here forever, right? After his usage, he would definitely move out of the network or go from your home. In that case, there is actually a scale down to the number of device. Now, this is a very example in the most lowest or the base level that I was telling. When we are talking about computer network or when you're talking about an internet connectivity, it is just connection of computers all over the world, right? So in this case, you would have a number of devices getting added up daily, or you are having devices getting modified. So in this case, network has definitely to support something called as scalability, and the scalability brings in as the advantage of computer networks. So what exactly are the different advantages of computer networks? It facilitates sharing of resources. It facilitates sharing the storage space. As we say, it is being able to access files from other networks also, right? And then sharing of software. Now, software can be installed centrally rather than on each machine. Now, in this case, when you have a client server model, you can actually share the resources or share the software, right? And then you have the enhanced communication because in due course of time or as time has proceeded, we have seen that there are multiple ways in which you can communicate with a person across the globe, right? So the technology has proven to you that the time and distance is no matter, and you can communicate with anybody anywhere on the earth at any time using any device, right? So this is how the computer networks has in it the advantage of enhanced communication. And how about cost reduction? Cost reduction because it the resource sharing actually cut down the cost, right? So hence cost reduction, and what we finally told was scalability. Now when we are learning the advantages of computer networks, we see that it is some or in the other way related with all the needs that we discussed before. Okay, what exactly were the needs? The communication, the reliability, and the resource sharing. So it is some or the other way. It is related with the need of having a computer network in the current scenario. Okay. So moving on, as I told you, when we see one side of the coin, definitely the other side also has to be explored. So now let's see what exactly are the disadvantages of networks. Fine. Usually there are, when we talk about this, we talk about mainly about the advantages, though there are a little of the disadvantages wherein, see here, the systems are sophisticated and complex to run. Now, in due course of time, with the advancement of technology, we see that as the work of the humans get much easier, the systems also get more complex and sophisticated. Right? Right? So, in this case, when we talk about the complexity of the system, definitely it's going to increase because it has to. Yes, good afternoon, Madhav. Welcome to my class. Okay. So, so when you are talking about the disadvantages, so this is one disadvantage because to support the current scenario and to support the current technology, naturally your system should be accustomed with the needed hardware as well as the needed softwares, right? And you should also have a high-end performing system. In this case, the systems get sophisticated and complex to run. Okay. Now we are relying on the systems or we are relying on the network too much, right? So in this case, if they are badly managed, now these are the things that we talk about the service providers. If the service provider is managing your network very badly, what happens? Now the services becomes unusable because if you're talking about a product also, if you get a negative feedback, do you think you will go and buy that product again, or would you recommend the same product to anybody? No, right? Now, once you purchase a new product from the market and you get a good, you experience something very good with respect to the feedback, it is quite natural and human that you would naturally advertise the product and also you would naturally recommend it for others. And for your own use, you will be highly recommended or you will highly use that product again and again. Now, this is the nature when we come with networks also. Now, when something is badly managed, that means the service is very poor. Now, what happens? It becomes unusable and hence the productivity falls. Okay. Now, if the software and files are held centrally, okay, now it may be impossible to carry out any work if the central server fails. Fine. When there is a central control over everything, now we told that in the case of advantages, when things are managed centrally, actually there is a provision for sharing and wherein you can reduce the storage space, you can reduce the cost cutting with the concept of central sharing, right? Now, but the disadvantage when you consider about a central authority is that whenever the central server fails, or there can be a chance that the central server fails, in this case, it would be impossible to carry out any work because a resubstitution has to be done or the working environment or the workload has to be distributed to some other system. We actually come across this when you are using phone networks or internet also. So whenever we see that there is a discrepancy or a breach in the central authority, we say that yes, the server has failed and things would be resumed only at a later point of time. Okay, I bet everyone would have experienced this in some or the other way. Fine. So this exactly, when you can call as a disadvantage of the network. But see here, though we talk about advantages and disadvantages, we see that the disadvantages are less in number. And as the technology has advanced, we have also seen that most of the disadvantages that we are listing here as bulleted are almost covered or rectified in some or the other manner because otherwise, such large crowd wouldn't be switching over to networks. Fine. Yes, now we're going to see the different components of a computer network. So we have learned what exactly is the definition, why should we go for a computer network, and also the plus and the minus with respect to a network. Okay, so we have listed them as bulleted points and we have learned them. Now we need to see what are the different computing devices that make up a computer network or what are the different components. Now I have listed a few of them here. As per the syllabus, you need to learn these components mainly. Host or nodes. Okay, in the coming slides, we'll be looking into the definition of each one of them. Then we have servers, client, the network hardware, communication channel, the software, and the various network devices. Okay, just a second. Okay, so these are the components of a computer network. What are they? As listed below, we have the host or the node. Then we have the server, we have the client, the network hardware, communication channel, the software, and the various network services. Just a second. Now let's see each one of them in detail. So components of a network means, in short, they are the participating entities in your communication or in your network. Okay. So the first one is host or nodes. Okay. Now this refers to the computers that are attached to a network and are seeking to share the resources of the network. So definitely when you're talking about a network, we know that there are multiple resources inside the network. Now when me or a device becomes a participating entity inside the network, what happens? The resource of this network is also liable to be shared, and this particular device gets access to the resources of other devices in the same network also, right? So when we talk about host or nodes, these are nothing but again a computing device, or in fact it is a computer. Now this is attached to the network and are seeking to share the resources of the network. In turn, it is also enabling to share the resources of its own device. Okay. Now the other name for host or network are workstation. So whenever a computer gets attached to a network, we call it by the name. It's a workstation or a host or a node. Okay. So these would be the terminologies that you would be using when you come across when you're talking about something called as a network. Okay. When you say that there are no nodes, you definitely have no network running. What exactly is that? It is a standalone system. So when you're working alone, I mean, when your PC or your desktop is working alone without getting connected to any of the networks, then that particular device is a standalone device. And when it becomes a participating entity in a network, we call it by the name host, node, or workstation. Okay. So coming to the next terminology, which is that it is the server. A server, it is a computer that facilitates sharing of data, software, and hardware resources and communication among the host possible in the network. Okay, so when you talk about a network and when you have a concept called as a server, actually server is a person which is considered a level higher to all the other devices, for the reason that this device or this server is a computer which enhances the facilitation for sharing of data. Now the data can be any sort of information. Now other than the data, I mean the resources can be the software, the hardware resources, and also communication. Now it is via the server actually you can get connected with all the possible nodes or workstations in the network. If you're talking about a computer lab in your school, okay, again, this is connected. I mean, it is a computer network, okay. All the systems are connected to each other and they are being controlled under the main system, which is called as the server. Now, apart from a computer lab, you would have systems in various staff rooms, right? And then you would have systems in the principal's room, in the director's room, and in the office, administration office. You might have one for the billing in the canteen. You would have one in the store, okay? Now, but all the systems would be connected to each other because these are all the systems of the all the systems of the school, right? So they are connected in some or the other way. When you're talking about a computer lab, therein also you are having a number of systems, and all these systems are going to be connected to one another. So, since the systems are connected, there has to be a system which is going to modulate or which is acting as a moderator or which is governing over all the other systems. So the main system which looks after or which facilitates the resources for all other workstations or host is called as the server. Is the idea clear? So this exactly is the server. So server is nothing but a computer that facilitates the sharing of data, software, and hardware resources and also communication. Now all these things are made possible only because you have a server connected to the network. Okay. Now, in short, what is it? So, in a single sentence, if you're trying to say what exactly the server machine does is it makes networking task happen, or in short, it makes the computer network, something called as computer network, happen. Okay. Now you have a teacher and you have the connected students, right? So in this case, the students are all connected with the teacher. So what do we call this as? The teacher will be the server here, and all the students connected or learning from the teacher can be considered as the clients, the terminology client that we'll be seeing later on. Now, another thing that you need to understand here is a network can have more than one server also. Okay. So, why it is having more than one server? Because we do not want to take the risk of the disadvantage that if this server or the central system fails, you need to find an alternative, right? So in this case, we can say that not just one server, it might have more than one server also. And based on the applications, also you would have different servers, each dedicated for a specific application. So these are all with respect to a server. Now, as I told you in the example, when we are talking about a connected system, the main system would be treated as the server and all the connected devices would be the client machines. So herein, when we are talking about the teacher and the student, we can consider the teacher to be the server and all the connected students corresponding to the particular subject that the teacher is teaching can be considered as the client. Okay. Now, more on servers. Now, on a small network, all the shareable stuffs are stored on the server. Okay. Now, like what we told about a small lab or something, lab setup in your school, in that case, all your client machines are governed by a server wherein all the shareable stuff, so all resource sharing stuffs would be definitely stored on the server. Now, each server will have a unique name on the network. Now, why a unique name on the network? For it to be identified in the network. Now, and all users of the network identify the server by its unique name. Now, all the users of this particular network, they're going to access the main network via the server. Okay, so definitely they will also be using the unique name on the network to get access to the major or main network. So what you need to understand here is, though you name it by the terminology server, it is also a machine. So it is definitely going to have a unique name which is going to be identified in the network. So this is usually a logical address here. Okay. Now the server itself is a computing device. When you're talking about big networks, okay, when you're talking about big networks, now this is not just one server you would be talking about. You would have different servers which are dedicated to the specialized task. So each server would be serving a specific purpose. Okay, for example, file server, which would be taking in account of all the file activities. Then you would have a printer server. Okay, now this takes handles all the printing requests and so on. Now, all the file related requests would be handled by whom? The file server. So hence, when you're talking about a very big network, it is not just one small functionality that the network would be doing. It would be doing multiple functionalities, right? In this case, we can say that there can be multiple servers which are dedicated to specialized tasks, and a few of the examples have been listed here. Okay. Yes. So moving on. Now, let's see the different types of servers when you're talking about a very big network. Okay. Now these are just a few of them. You can have more number of servers also. You would definitely have a primary server, which is the main server. Okay. So in a LAN, now we'll see what LAN and the different types of networks are in the coming slides. So the main server in the LAN, now this has a network operating system running in it, and users have to first log on to the primary server. So this is where you need to first log into, and only then you get access to the machine. Okay. So this exactly is what you mean by the primary server. Then you have the file server. Okay. Now as I told you, all the file related operations are concerned or would be considered by the file server. Now, what does it do? It serves the files for the users in the network, keep user files and programs in its disk storage. When the client requests for the files, the server locates them and sends to the client. So, whenever you are having a server client architecture, okay, so the main or the system at a higher hierarchy is called as the server, and all the systems that are interconnected, I mean at a lower hierarchy than the server, are called as the client machines. Now what does a client machine do? Always it will be asking for or it will be requesting for some sort of the resource. When we're talking about a teacher student environment, I told you that the teacher can be equated to be a server and the students can be equated to clients, right? In this case, the clients always request for information from the teacher, right? And what does the teacher do? Now, the teacher, if he or she knows the topic, definitely the teacher would be teaching them, or else the teacher would refer somewhere and then um, get it to a reachable point to the student, right? So what happens exactly in a client server architecture also is that whenever a client is requesting for the files, now the server has so many files stored in its storage. Now there will be categorization on the files. Now it will be keeping user files and it will be stored in the disk storage. Why? Because when we learned files, we learned that they are used for persistent storage, and hence it would be managed by the server, or it is, since for persistent storage it is going to be definitely stored in the hard disk. Now what the server does is, whenever it gets a request from a client machine, it will start hunting where exactly this file is and sends this corresponding file to the client. Now this type of server client communication happens only when the file related operations are being performed, and hence this is called as the file server. Okay. Now next moving on to the application server. Fine. Now, if file server was something related with files, now let us see what application server would be doing. Now, application servers provide specific services at application level like database server, web server, etc. So, whenever you're connecting or when you're doing things with the web pages, definitely the server that would come for your aid is the web server. Whenever you're doing operations with respect to the database, okay, when you're talking about data which is being stored in the database and you're requesting for the table of information via a query, now the person who comes to your help would be the database server. So in this way you would have the different application servers, okay, with performs specific services based on the different application. Okay. Now we have the print server. Now as we already discussed, what does it do? It does all the printing services for all the users in a LAN. So there will be, when you have a connected system and when your resources are limited, so naturally you need to have a person to have controlling or monitoring the usage of the resources, right? So here comes the help of the print server, now which is actually modulating or monitoring all the printing requests that is coming and then facilitating the printing action. Okay. So these are the different types of servers. Now let's see what a client machine is. Now when we learned servers, we learned that it is a computer which is facilitating all the requests, okay, or it is satisfying all the requests from the host, right? Now all the host or the past participating entities in the network connected with the server is called as the client or the client machine or the client computer. Is the idea clear? So a client computer again is a host computer. Why a host computer? Because it is a participating entity in the network. Okay. Now what does the client machine do? This client machine always requests for some service from the server. Okay. So what exactly the client machine does is it actually requests for some service from the server. Just a second. Okay. So a server computer serves the request of the client machines or client computers. Okay. So a request would be put forward by the client machine, and what would server do? It would be serving the request, or it is actually a solution. It is a problem solver. Who is a problem solver here? We have the server who is a problem solver, and whenever the client machine faces a problem, the machine would address it to the corresponding server, and here is how the server gives a solution to the problems and hence becomes a problem solver for in the client server architecture. Okay. And next is the network hardware. A network requires specialized hardware to carry out various roles like establishing corrections, controlling the network traffic, etc. Okay. So whenever we are talking about the network, it is not just the system that we need to talk about, but we need to talk about other devices or the other participating entity in the network which would enhance or which would help in facilitating in the concept called as bringing out networks. Okay. Now how does it do it? A network requires specialized hardware. Okay. Now to carry out various roles. Now what are the various roles? It involves establishing corrections, controlling the network traffic, etc. Now a few of the examples of network hardware are being listed here. We have NIC, which is the network interface card. Okay. So this is a network interface card which is attached to a host so as to establish network connections. Okay. So every system would have an NIC card in it embedded. Now this NIC card would have some address. Okay. Now this would be a unique address. Now what does it do? It is a network card. Now what is the help of this card? Since the definition itself says that it is a network card. So this is a card which enhances network in the system. Okay. So once you have the NIC card, what does it enable or how does it boost the system? It boosts the system by enabling the system to have network connectivity. Fine. So it is a network card attached to a host so as to establish the network connections. So to establish network connections, you would have something called as the NIC card. Okay. So networking devices. Now, do you think that you just have computing devices inside your network? No. See, one device has to be connected to the other using either a networking device or simply the connection wires. Okay. Now, there are networking devices like hub, switch, and routers. Now, when you're talking about network, it is not something that starts from a point and after a few meters, the network is going to end. Then, if this is the case, how do you think the entire world can be connected and you can make the world a shorter space, right? You definitely need to think about it. So, in this case, it is not just the computers or the participating entities that make up the network, but you also need to consider all the networking devices, like the hub, the switch, the routers, etc. Now we'll be looking into the different networking devices, each one. Okay. Now prior to that, let us see what is a communication channel. So communication channel, see here, the channel is nothing but a connectivity that connects between the device and the computing device, the different devices. Now see here, this is the mouse, okay, the mouse of your system, and you see a wire running from one end of the mouse. Now it will have another end wherein you connect it with the system, right? So you have a connector. Now this is how the mouse would look like. So this is actually a device which is going to be connected to your system. Now I'm not talking about a networking device but a hardware. Now how is this hardware getting connected to your system? You have a wire running, right? And you have an endpoint. Now what is it done? Whenever you connect this endpoint to your system, what happens? The action of the mouse can be enjoyed there, right? So similarly, all these network wires or the group of wires running which helps in the connectivity of the different systems is called as the communication channel. Now see, imagine a classroom teaching wherein you have a teacher as well as the students. And now, whenever the teacher is talking or taking class, what happens? It gets broadcasted to every student. Now, what do you mean by the term broadcast? Okay, broadcast meaning you are actually reaching out to everyone or every participating entity in the network. Okay, so this is what you call by the term broadcast. When it is a unicast, actually, it is nothing but a one-to-one conversation. Okay, when the teacher, imagine a teacher taking a private tuition, in that case, for a student. So, in this case, this is a unicast communication between the teacher and the student. Okay, now when you're talking about multicast, okay. So imagine that this is a co-ed school, okay, and in my class I would have boys as well as girls, and I'm going to assign a project for the class. Now, how I'm going to assign is I would assign a different project for the boys group, and I would assign a different project for the girls group. So in this case, it is a multicast communication wherein you are taking a selective group from the full network and then communicating to the selective group. Okay. So whenever you're having a selective communication, you call by the name multicast. Whenever the information sent from the main system is getting broadcasted, is reaching all the other participating entities in the network, we call it by the name broadcast. When you're only aiming at a destination device and the source is only trying to communicate with the destination device, we call it by the name unicast. Okay. Now, to understand all of these different types of communication, uh, this is where we talk about the communication channel also. Now, as I told you, you have some or the other medium or wire which is getting connected to the system. Now, this would help the host or a system in the network to interact with other hosts and servers. Now, all this can be done only with the help of a medium which we call here as the communication channel. Okay. Now, this channel can be either wired or wireless. Now, as I told you, you have a wired mouse as well as a wireless mouse also, right? Wherein you have a chip which is to be, something like that of a pen drive which is going to be, or a dongle which is going to be connected to your system. This dongle is a part of your wireless mouse, and that you connect with your system and then use the wireless mouse, right? So, in the daily life also we see devices which can be wired and used, and which are also wireless and which can be used. Okay, so when you're talking about the communication channel, it is nothing but the medium. So when you have participating entities, whenever you're talking about something called as communication, okay, just a second, let me erase this off. So when you have a communication, then you have participating entities in the communication, right? Then I can talk of we have a source and we have a destination, right? So whenever a system is trying to send a message, we call that particular system as the source, and to which particular device is the source sending the message, and that particular device would be called as the destination. So in a communication, the participating entities include the source, the destination, right? Apart from the source and destination, you have a channel or a medium via which the communication can be enhanced, right? So, there comes the communication channel. So, whenever you're talking about communication, it is not just the source and destination that are the participating entities. We also need to talk about the medium, communication medium that they are going to use. The channels can be either wired or wireless. Wireless, in the case, it will be using air as the medium, and some technology wherein you communicate with the device. Okay, fine. So these are the things with respect to the communication channel. So let me take a sip of water. So next we're going to see the different wired and wireless communication channels. Now, see here the difference. As I told you, we talked about the example of a mouse, right? Wherein the mouse can have both wired communication. The mouse can be either wired or wireless. Okay. So, just a moment. See here, in the wired communication channel, the other name for it is guided media. See, whenever you are having a connecting wire, see here, whenever you're having a connecting wire, now this is a guided medium because the signal can pass only through this wire, right? So hence the same thing with connected with the networks also. Whenever we're talking about a wired communication channel. This is a guided media like the network cables. Now, for the enhancing of wired communication channel, the different examples are the twisted pair cables, the coaxial cables, and fiber optic cables. Now, these are the main things that we'll be learning today. So, as I told you, the wired communication channel are guided media. Now, the terminology or the little meaning of the term guided, what does it mean? Guided meaning it is actually showing a path for the network cables, right? So, whenever you're having a wire, it is only via the wire that the information can pass. Right. So the different guided media include twisted pair cables, coaxial cables, and the fiber optic cables. Okay. Now, what about wireless communication channel? Now, these are unguided, right? Now, in this case, we actually have to take the help of, we would actually talking about the atmosphere, wherein the atmosphere becomes the medium. Okay. So unguided media means it is not having any physical wire which would say, yes, this is the path via which the signal has to transmit or the travel. So it would be having an unguided media. Now, for using the unguided media, the signals or the waves that take help of unguided media are the radio waves, satellite communication, etc. So we know that the radio programs as well as the television programs, we always do not have a wired communication. Now, how does it reach the radio? It actually reads through the broadcasting of the signals from the radio station, right? So actually it is taking the help of a wireless communication channel. Fine. And even in the case of TV channels, we have also seen when we are having the dish antenna or something, right? You get access to all the TV programs running in the different channels, right? So not every time you have a wired connection here and also you use the wireless communication. And when we are talking about satellite communication, okay? So when we are talking about either satellite telephones or satellite TV, okay, all these communication again is a wireless, but we cannot imagine wires running hundreds and thousands of kilometers up and down here. So in these cases, we take the help of unguided media, wherein we would be using the atmosphere as the medium of communication. Okay, so here this is the wireless communication channel. Now hence goes with the difference between wired communication channel as well as wireless communication channel. Now, when you're learning about the wired communication channel, you need to learn in detail about at least the main of them, which are the twisted cable pair as well as coaxial cable, which are also called as coax, and the fiber optic cables, wherein the fiber optic cables are the most popular ones and are being used today. Okay. So, moving on, we'll be looking into the different communication media later on. So, let us now cover the different participating entities in the network, wherein we had seen the components or the participating entities as host or nodes. We saw the servers. We saw the client, the network hardware, the communication channel. Right now we just saw was the communication channel. And now we are going to see the software. Okay. Now what exactly is the software? Now the software layers of a network make networking possible. Okay, the software hardware is something that a physical component that you can feel, touch and see, right? Now software is not something like that. It is actually a concept here. Now what concept? These are all programs, right? Now, these are programs that are written for the functionality of the network to happen, right? So definitely a network would be layered with different softwares, and at each layer a particular software would be working. Now, this software are the ones which would make something called as networking possible. Is the idea clear? The software layers of a network are something which would make the concept of networking possible. Now, what are software comprised of? They are comprised of the network protocols as well as the network operating system, etc. So the softwares or the software in the computer network, they are comprised of protocols and as well as the network operating system. Now let us see what are protocols and the operating system. Now protocols are nothing but pre-decided set of rules. Okay. Now you have a set of rules which are pre-decided, means before entering into a network or before entering into a communication, the rules are set and you need to follow these rules. Only then you can engage in an communication in the network. Or in short, you can be a workstation or you can indulge into a communication or a conversation in the network only after following the pre-decided set of rules. So all the set of rules and regulations which all the parties of a network connect and interact with one another. Now, pre-decided set of rules. Now, these set of rules has to be used by all the participating entities of the network, or something like we say all should abide by the rules. I mean, all in the network has to abide by the rules. Now, when you're talking about a school, when you're a student in the school, you are given with a set of rules and regulations which will be printed in the hard copy, maybe listed as do's and don'ts in the notice board. You would have the rules and regulations to be followed in the school given to you in the school diary, right? Now, all these are pre-decided and pre-decided by the management, and these are the set of rules given to you. Now, once you are a student of that particular school, you need to abide by the rules, right? So, this is how, as a student, you get connected with the school. Similarly, when you're talking about a network, we talk about something called as protocol. Now, these are nothing but the pre-decided set of rules. Now, what are the rules set for? These are used by all the participating entities, be it a workstation or be it any hardware that is participating in the network when it is trying to connect and interact with one another. Or in short, when you're trying to indulge into a communication in a network, you need to abide by the protocols of the network. Okay. So next is the network operating system. Now this is a specialized operating system. Now why? Because this is specialized so that it can handle the networking task. Fine. So the network operating system, the specialized operating system that can handle the networking task. So this is the operating system that is designed particularly for the different network operations. Now the protocols and the network operating system are in short making the different software layers of the network. So the network is programmed so that the participating entities abide by the protocol, and there is an operating system which would guide what is to be done where and how in the case of a network and its communication. Okay, so next is the network services. So network services, it refers to the applications that provide different functionalities over a network. Okay. So services means some functionality that is or applications wherein you can enjoy it, right? So when you're talking about network services, so these are the services provided by a particular network. So what are they? They refers to the applications that provide the different functionalities over a network. And the different examples for the network services are DNS or the domain name system. Okay, the file sharing and VoIP. What is VoIP? VoIP is voice over internet. Voice over IP. What is IP? IP is nothing but the internet protocol. So when you are able to transmit voice over the internet protocol, say for example, the broadcast of the class that I am right now doing live in the session is an example of a VoIP wherein I'm sitting in my home at the comfort of my home and then broadcasting or taking a lecture online via which the same lecture is going to reach each one of you, right? Now it is taking the help of internet. So we need to talk about the protocol that is being used in the internet, which is the basic protocol is the internet protocol, and the voice, that is the analog signal, is going to get transmitted over the internet protocol and then reaching each one of you. So the network services, it refers to the applications that provide the different functionalities. So for the different functionalities in a network to function, now what is to be provided? It refers to the different applications. Now a few examples of them are listed here, whereas DNS, domain name system, the file sharing, wherein it is an application wherein you get access to the files, may be stored in the server machine or may be stored in some other device. And then you have VoIP or the voice over IP, as we have just right now told. Okay. Now moving on. Okay, so we are going to see the different types of networks here. So a network means a small group of linked computers to a chain of a few hundred computers of different types spread around the world. Okay. Okay, so we're going to see the different types of networks. So prior to seeing the different types of networks, we need to understand how the categorization goes. Now, when you're talking about a network, it can be either a small group or a big group, right? Now, a small group means a small group of linked computers to a chain, right? A chain in the sense you're talking about a bigger network wherein the scalability has increased. Now what is scalability? When you talk about the increase in the number of devices, right? Okay. So a network means it is a small group of linked computers to a chain of a few hundred computers of different types. Now the spec of your systems can vary. Okay, you may be using a smartphone, you can use your smart TV, you can use your laptop or your desktop. Okay, now the devices would also differ, and when there is a connectivity among all these systems which are spread around the world, we call it as a network. Now, these networks, as you see, they can vary in the size in the sense it is not just that it is just within 1 or 2 meters. It is like you talk about the scalability, the number of devices attached to it, for how much kilometers can this network range go up to, whether it is just in a building or whether it is in a city or when you are connecting over cities. Now all these things. Okay. Now the complexity actually involves with the devices that is involved in the network, and then finally the geographical spread. Okay. Now here comes the distance when we calculate, and this is also a category among which we categorize something called as networks. So how are networks classified? They actually vary with size. Okay, now the size usually takes into the count of the number of items that are participating in the network, then the complexity, and finally the geographical spread. So these are the ways or the parameters on which the different networks vary from one another. Now we are going to see the different types of networks based on the geographical spread. Okay. Now what are we trying to see? We're going to see LAN and WAN. Now apart from this, we also have other networks like metropolitan area network, where we say as MAN. We have PAN, which is a personalized area network. We have a disk area network, which is the DAN. Okay. So likewise, we would have different type of networks also, but according to the syllabus, we need to learn only the two networks, which are LAN and WAN. These are the types of networks based on the geographical spread. What are they? Local area network as well as wide area network. Now, what is the categorization based on? The categorization is based on the geographical spread, right? So in this case, local area network means you're talking about a very small geographical area, and when you're talking about wide area network, you're talking about kilometers and kilometers. Okay. So this is exactly is the difference when you're talking in terms of geographical spread. Now we're going to see each one of them in detail. Okay. Now the first thing that we see here with respect to LAN or local area network is that it is having a geographical spread of around 1 kilometer. See, when you're talking about a connectivity, say in your school, okay, or in a particular building or for an office, in this case, what you call is called as the LAN network. Okay. So these are small computer networks confined to a localized area. So what exactly can be an example for a localized area? Either a school wherein you have all the computer devices connected to one another. Now a setup which is inside your lab, computer lab, can be called as a LAN. A setup which is connecting all the devices in your school building can be considered again as a LAN. Now, a setup of connectivity, when you're talking about a connection in a building, in a particular building, in the office, can also be called as a LAN. Now, as we told, the key purpose of networking is nothing but resource sharing. Now, this is getting applicable here also. In the LAN also, the main purpose of getting connected is the resource sharing, because a system will not be having all its resources wherein it can get access to all the resources which is getting distributed among all the systems in the network. Okay. So, in a typical LAN, one computer is the file server which stores the software that controls the network, as well as the software that can be shared by the computers attached to the network and others to the workstation. Okay. Now, in this sentence, we're going to see that in a typical LAN, what are the participating entities and how are each of the participating entities behaving. Okay. See, when you're talking about a typical LAN, so definitely when we talked about a LAN, I told that it is a small computer network. So naturally, you have participating entities in the network. These are all computers, right? Now, these computers are connected. Now, one computer in the typical LAN can be considered as a file server. Okay. Now, this stores all the software that controls the network, as well as the software that can be shared by the computers attached to the network. So there'll be a file server, meaning that you have a main system which is taking the control over the network, right? So this would be your main system, and this is the one who is monitoring the functionalities of all the other participating entities in your system. Now let us call that to be your primary server or your file server. Now this file server will be storing all the softwares that controls the network. Is the idea clear? So this is the primary server or your file server. So what would it have? It would be storing all the softwares that are required for controlling your network. Fine. Now, apart from that, do you think it is just having the software for controlling the network? No, but it will also have mechanisms. The mechanisms can be again the software or the hardware resources. This can be shared by the other participating entities. Okay. So, when you're talking about a main server, it is actually a very huge machine which is voluminous, which can store voluminous data, as well as what it does is it is having software which controls the network. Okay. Now this software, the activity or the primary aim of the software is not only controlling the network but also the participating entities. Okay. So when a teacher is in a control of a class, now what he or she does is he or she is not just teaching you but also having a control over the class. Now the responsibility of the teacher is also to see that there is discipline maintained in the class, right? So each student is monitored differently, and he or she also makes sure that each of the student understands her class, right? So each student would be having a different capability of understanding. Now, in due course of time, a good teacher will understand all her students. So in this case, he or she would be teaching in a manner. Yes, Harsh, good evening and welcome to the class. Okay, so in this case, what would happen? He or she would be looking into the student capacity and teaching accordingly, right? The same way, a file server or a primary server, what it does is it has to control all the other participating entities, right? So what would it do? It would actually store all the software to control the network as well as the software which can be shared by the computers. Now, there are certain resources which cannot be stored in individual system. It will be stored in the memory of the file server, right? So, this can also be shared by all the systems, and others are the workstations. Okay. And when you're talking about the geographical spread or the restrictions with distance, it can range up to 1 kilometer, or it can be, plus or minus 1 more kilometer also. But once when it goes out of this distance criteria or the geographical spread, we call the network by the name WAN. What is WAN? Wide Area Network. Okay. Now herein again it is a network. So you would have a group of computers that are separated by large distances and tied together, right? So again, you're talking about a group of networks, a group of computers, because you're talking about a network here. Now, how are they going to be separated? They are going to be separated by larger distance and they are tied together in the form of a WAN. Okay. Now, there can be group of LANs. Now, inside the WAN, or inside the wide area network, you can have groups, small groups, right? Now, each of these group can be a LAN also. Now, that are spread across several locations. Now, if you're taking an example of an office, okay? Now, let me take my company to be ABC Corporation, okay? Now, this ABC Corporation has concerns running over different states in India, right? Let me, or maybe in the same state it is having in different locations, different cities. Now, in this case, what I would say is this ABC Corporation is having a concern at a place X. It is having a concern at place Y. It is having a concern at place Z and maybe AB. Okay. Now, these are the different locations wherein the ABC Corporation has its offices or branches running. Now, if you're taking about banking sections, also you have a bank with its branch running over different places, right? When you're talking about a particular office, say you're talking about the office setup in the location X. Now, this location would have a LAN connectivity. Now, definitely would each of the branches here have, right? Now, each of them would be having a LAN because the connectivity is either in a single building or in a room or something like that, right? So each of the location would be having an individual LAN connection, but when you want to connect all the branches together, right? Now this is definitely going to spread over a very great geographical area, maybe other than 1 or 2 kilometers. It would have kilometers and kilometers, a very larger distance, right? Now in these cases, all these LANs are connected by a network, and this network would be called as the WAN here. Fine. So this is what is meant by the second bullet. What it means is inside the WAN you can have a group of LANs, right? So what is WAN going to have? They are going to have a group of LANs, and these LANs are going to be spread across several locations and connected together. Okay. Now WANs facilitate fast and efficient exchange of information at lesser cost and higher speeds. Now, what does wide area network facilitate? This facilitate fast and efficient exchange of information. Okay. Now, in LAN also we have the same features. We talk about exchange of information, we talk about cost reduction and also speed of communication. But when things are getting spread across over a larger geographical area, now what we speak about here is what we speak here is we're talking about a larger coverage, right? And we are able to reach at a greater distance at a lesser time. Okay, so that means higher speed. So when all these typical lines, local lines, are getting connected over with the help of a WAN or a bigger network. Now, definitely this WAN would facilitate fast, efficient storage, efficient exchange of information at lower cost and at higher speeds. The largest WAN is the internet, which is getting connected, which makes the world a very smaller space by connecting every point in the globe and making it reachable. Okay. So it is in this pandemic situation we actually knew the importance of internet also, whether it becomes the case of a study, okay, learning process, maybe the working process, the work environment, everything was done online. And this was where we understood the actual advantage of having a van. Though we were enjoying it otherwise also, but it was a situation like this which made us understand the real availability, the real need for having such a network. Okay, so be it for professionals, be it for students who are trying to learn, for everybody, the connectivity had made them feel that they are not going to be very far away from each other, but still they are getting connected. Is the idea clear? So the largest WAN is nothing but the internet. Okay, so other than that, we need to see a variant of it, which is MAN. MAN, as I told you, is the Metropolitan Area Network. Now, this network is spread over an area as big as a city. So, whenever you're having a connectivity in a city, it is called as a MAN, though it is a variant of WAN. Okay. So it is just a categorization, and when you connect the cities together, what do you end up in? You end up in WAN, because it gets spreaded across a very larger geographical area. Okay, and when you're talking about internet, it is the largest WAN. Okay, so these are the things that we. I'm so sorry. There's a mistake here. Okay, so the mistake is with respect to, we are going to compare the LAN, that is the local area network, with the wide area network. Okay, when you're talking about the distance, okay, LAN considers a covering over a very small area of network, whereas WAN considers spreading over a very large area. Okay, so it can move beyond countries to countries also. Now, when you're considering the cost or the expenditure for setting up a LAN and a WAN, we know that when you're considering a LAN, we need to talk about a very small area where we are going to set this up. So in this case, the cost is less to set up a LAN. But when you're talking about a WAN, it is actually very expensive to set up. Why? Because you need to purchase bigger networking devices, and you need to extend it to a larger space. Okay, so the participating entities, the communication wires to run, the hardware involved, now all this would make it more expensive. Okay, now when you're talking about a LAN, it is usually a single network, and when you're talking about a WAN, these are usually a network of many networks. And this is why, this is why, what did we say? We told that it is a group of LANs actually that are spread across several locations and connected together when we were talking about the definitions with respect to WAN. Okay, so just a second for. So I hope the idea and the comparison between LAN and WAN is clear to you. Not a big task, and it is a very simple thing, and we usually come across all these things, though we do not know each one of them in detail. And this is how, in a nutshell, how you classify or differentiate between the two networks, which are classified on the basis of the geographical distance. Okay. Now that we're going to see the types of networks based on the component rows. We saw the types of networks based on the geographical distance. Now we are going to see the ones based on the component rows. Okay. Now, on the basis of the roles played by network computers in the network operation, computer networks are classified into peer-to-peer networks and client-server networks. Okay. Now, the client-server model we already saw, but we'll be looking into here also in detail. Now, let's see what is peer-to-peer. Now, what exactly is the literal meaning of the word peers? Okay. Now we talk about peers when we are talking about people of equal grade or equal stature. Okay. So at par with, right? So similar is the case here also. When you're talking about peer-to-peer networks, we are talking about systems at the same level. Okay. Now when you're talking about the systems at the same level, it is called as peer-to-peer network. Okay. And this network is actually implementing the literal meaning of the word peer. Okay. Just a second. So, on the basis of the role played, we saw that there are two classifications, which are called as peer-to-peer networks as well as client-server networks. And in peer-to-peer networks, we told that every system is having an equal level, or there is no hierarchy here. Every system are equal participating entities in the network. But when you're talking about a client server network, you have a machine which is actually on a higher level when you compare to all the other devices, though all the devices are connected to each other. Now, this particular system, which is having a higher priority or a higher level, is called as the server, and all the other devices which are connected to the server are called as the client devices. Okay. Now let us get to see them in detail. So peer-to-peer networks are also indicated as P2P. Okay. So P2P networks. Now each computer on this network is equal. See, as I told you, here there is no nothing called as a server or a client, or some machine is having a higher priority over the other. All the machines are having equal priority and treated equally also. Now, each computer controls its own information and plays a role of either a client or a server depending on the requirement. Okay. Now, suppose there are two parties going to be involved in a communication. Now, the parties would be naturally the computing devices, right? Or the computers. So, each computer controls its own information. So, every system is responsible for the information that it holds, right? So, and if it is going to get participated in a communication, what happens? It would play the role of either a client or a server. So, see, if a device A and B in a peer-to-peer network are going to communicate with each other, right? So, suppose A wants something. So, A is requesting something from B. Now, in this case, both of them are communicating and B is actually serving the request. Okay, it is actually accepting and serving what is being needed for A. In this case, A is acting as a client machine and as well as B is acting as a server machine. Now you can talk about another scenario wherein some other device C is requesting a resource from the A. So in this case, now the role play changes, right? Wherein C becomes the client and A becomes the server. Now, every device can be either server or client here, and none of the devices here are designated as, yes, this particular device is going to store voluminous data and this is going to act as a server. No, it is not going to be that way, wherein every participating entity is going to be treated equal and each computer would control its own information and plays a role of either the client or the server depending on the requirement. Is the idea clear? So this is a main point with respect to peer-to-peer networks, or how do you write it? P2P. Now, the computers here are also called as non-dedicated servers. Why? When you're talking about dedicated servers, the servers are dedicated for some specific functionality. Is the idea clear? The compute when you're talking about dedicated servers, they are um, okay, when you're talking about dedicated servers, they are dedicated for a specific functionality. Now, when you're talking about the devices or the computing devices that are involved in the peer-to-peer network, they are non-dedicated servers. Is the idea clear? What are they? They are non-dedicated servers. Now, for this reason, these are slower and requires more memory. An accepted limit is up to 10 computers. Okay, so these are the concerns with respect to peer-to-peer network. Now also that they are popular as home networks. Okay, now why as home networks? Because they can be in use in small companies. Okay, in small companies. Why? Now when you're considering small companies, we talk about the affordability, right? So peer-to-peer networks are less expensive, and hence it is affordable, and it can be used as small companies, and for this reason we say that they are as popular as home networks. Okay, now one more thing that you need to note here is there are no dedicated servers, wherein the servers here are not dedicated for a specific functionality as we talked about print server or file server before. So these are the case in which of the peer-to-peer network. Why do we not have non-dedicated server here? Because it is simply dedicated to the cause of serving, and hence and every system here are having equal right or responsibility. They are treated equally here. One is not overruling the others, and hence it is not completely dedicated to any specific purpose but for the purpose of serving. So every system, I mean every computing resource that is involved in this network are getting are doing or are serving the other devices in the network in some or the other way. Is the idea clear? So hence peer-to-peer network. Okay. Now why is it slower? Because see, the same system can take up the role of a server as well as the client based on the situation, as the example that we saw in the previous slide, right? Now in this case, this when the same system has to act or has to have the functionality of both the server as well as the client, the system tends to get slower and it might require more memory. Now when it is going to perform the function of a server, it is going to require more memory. When it is going to take the function of a client, then it would be taking lesser memory, right? So in these cases, when it involves more memory and more functionality, and when it has to act as a server. But remember, all the configurations for the system are equal, and they're going to be given equal priority and hierarchy also. Now in this case, when the equal priority system has to take up a role of a higher level, it would definitely affect the speed, and it would also affect the storage space, and it would require more space. Now usage of more space means reduction of actually the speed, right? Thus making the system slower. Okay. Now an accepted limit means it is a maximum up to 10 computers. Okay. Now so since I told you that everyone is treated as equal, and each computer can play the role of either a client as well as a server, we can say that no computer here is designated in charge of the network operation. Is the idea clear? No specific device is given the charge of the network operation. So whenever there are two participating entities which need to communicate, it is a duty of that particular system to get involved in the communication, to to actually give an indication to the destination device that such a communication is going to happen, and this is how it has to happen. Is the idea clear? So these are the details with respect to peer-to-peer networks. Okay, so moving on to the Next network. Now, which is this? Client server networks. Now, this is a network that we have been looking into for quite a long time, right? So, here in this type of networks, a system would be designated as a server. Now, this server is going to have a higher level consideration than all the other participating entities. Why? Because this machine or this server would be the one which is serving all the requests that would be coming from all the other devices. Okay, so let's get to looking into what the client server networks are. So when we consider the previous network, what was that? That was the peer-to-peer network. So whenever we are considering the peer-to-peer network, client servers are very bigger networks. Why? Because they prefer a centralized control. And who has the centralized control? The centralized control is always governed by the server, right? Now, since you have a specific device which is designated for a specific purpose, and all the other participating entities can get their request serviced from the server, the question of the question of the systems getting or the network getting slower or requiring more memory is not something a concern for us. Why? Because here all devices, in the case of client server networks, all devices are not going to be treated equal, they're going to be treated different. And also for this reason, none of the devices are working as a non-dedicated server. Instead, the device that is assigned as a server, and if you have different application servers, we have actually dedicated servers here. Okay, so it is just the headache of the server for maintaining the speed as well as the memory. Okay, so let's get to learning of client server networks. They are bigger networks that prefer centralized control, and we also saw that the centralized control is going to be served or going to be provided by the server to you. Now, how is this achieved? See, this is achieved by designating servers and clients, which are called client server networks. So, whenever we have a network wherein we have a machine which is having a higher priority or a higher level to be treated as a server, and all the other participating entities which communicate with the server for their servicing their request are called as a client machine, we call the network to be a client server network or a client server architecture, or see the other name that is being given. What is the other name? The other name to be given is master slave networks. Okay, wherein the server is your master and all the client machines can be treated as the slave. Though you find a contradiction in the meaning, because the client is actually requesting for it, and the master, that is the server, is actually serving the request or fulfilling the request that is coming from the machine, right? Now, another thing that you need to note here is you just don't have, your network is not that short to have just one server and a client. You would have team number of client machines. And every time the client machine would have some or the other request. Request of some or the other form. Okay. Yes, Gokul, good afternoon and welcome to the class. We are dealing with computer networks today. Okay, so as I told you that we are not talking about just 2 or 3 systems as the participating entities in the network. Instead, we have a team number of client machines. So definitely when it is a client machine, you would have a request pouring in from the client machines, right? So when it comes to the server, now there is some order in which the server is servicing or giving service to all the requests. It would not be taking up every request in the first hand. The server would have definite algorithms. Sometimes it would be taking a priority algorithm wherein depending on the work, depending on the priority of the work that is to be done, it would be getting the services done, or it would sometimes be taking the form of FCFS. What is FCFS? First come, first serve. So whichever work or request that is coming first is getting serviced first. Okay. So similar kind of, and we have a team number of algorithms wherein how to deal with the multiple service, I mean client service requests that are pouring in together. Okay. So a client computer is a computer or other device on the network that requests and utilizes the network resources. So what is a client computer? It is a computer or other device on the network that requests and utilizes the network resources. Fine. So server, now what is a server? As I told you, it is having a hierarchy one up higher when it compares to the other client machines. So it is a computer on the network dedicated to processing the client request. So what exactly is a server? A server is actually a computing device in your network, participating device. This is dedicated to processing the client request. Okay. Now, let us take for an example the web browser. Now, what does it do? It is a client which makes a request to the server and server sends the website to the web browser. Okay. So, what exactly is a web browser? Now, web browser is a client. Okay. Now, what does a client do? As we know that the client actually gives a request, right? Now, this request goes to the web server. Fine. Now this web server would find, now what exactly would be the request in the web browser? You would be typing in a URL wherein you want to find the web page, right? So this web page wouldn't be directly available at the web browser. What would it do? The web browser would definitely give the request to the server which is in control of it. Okay. Now the web server, like this web server would be having requests pouring in from different web browsers. Okay. Now whenever it gets a request from a client machine, nothing from the but from a web browser. Now what it does is it will search for the particular website, and this particular website is given as answer to the web browser, and this is how the web page appears on your screen. Okay. Now here again, what is the architecture that is used or the network that is used is the client server networks. Okay. Just a second. So what you need to note here in the case of a client server network is that a client is always dependent on the server. Okay. Because it is not just one client, you would have multiple clients and all the clients are dependent on the server. And something that you need to really take care of here is the server machine should never crash. Okay. Or an alternate solution has to be done for the server in case of any discrepancies. Okay. Now, since the client machines are fully relying on the server machines, and if the server machine happens to crash or comes into a trouble, naturally the entire communication gets affected, or in short, the network gets affected, and none of the client machines can run anything. Is the idea clear? So, this exactly is what do you mean by the client server networks? Okay. So next, let us see the differentiation in the form of a table. Okay. Now we have a differentiation. I mean the distinctions between the peer-to-peer networks as well as the client-server networks, and we are talking about the differences based on certain parameters, starting from security, the management, dependency, performance, and the backups. Okay. So security. Now the server controls the security. So client server, in a client server architecture, we know that who is the main holder of everything? Definitely the server, right? So whenever we are talking about the main activities, who will be holding or who will be held responsible for the activities? Definitely the server will be held responsible. Is the idea clear? So whenever we are talking about security, now security is a main feature that has to be there in your network. In this case, we say that the server will have the control over the security. Now the server machines will be having, security policies involved in it, or maybe it has certain protocols wherein which it gives a restriction to what is to be used and what not to be used. Fine. And then how about the security? Maybe the more higher versions of the antivirus softwares would be in the server machine. Okay, and this is how it would be extending the security to all the client machines attached to it in the network. Fine. Now, when you're talking about peer-to-peer network, now what is peer-to-peer? All are the peers, right? All are equal in this network. In this case, do you think would there be any central control over the security? There would definitely be no central control over the security. Okay. So this is the distinction when you're considering the point of security. What are we trying to compare? We are trying to compare the client-server architecture as well as the peer-to-peer networks. Now, whenever we are seeing each of the points, the thing that you needs to come to your mind is that see, we're talking about whenever we are talking about client server communication, the server is already having a higher level authority when compared to the client machine. So the primary responsibility always lies in the shoulder of the server machine. Fine. So what client does is whenever client faces a problem, it goes to the server or it raises a problem to the corresponding server. And what the server does is it is actually a solution handler. It gives all the solution to the problems raised from all the ends by the different machines. But when it comes to a peer-to-peer network, herein we do not have a centralized control. Instead, the control is distributed over all the machines. So whenever there is a participating entity in the communication, these two entities would be acting as a server or a client based on the situation. So in this case, what we try to understand is that there is no central control over the security. Now, if security has to be provided for the network, definitely each system is becoming an autonomous system, and this each system will have to have a security policy adopted in the system. Okay, or else what would happen? Every systems are treated equal, and when there is a discrepancy or a virus infection in a system, it is likely to get carried over to the other communicating devices fastly in the case of a P2P or a peer-to-peer network. Okay. Now let's get to see the point on management. Okay. The server manages the network. Okay. So in the client server architecture, who is the person who manages the entire network? Definitely the server, right? In the peer-to-peer network, no central control over the network. Why? Because all participating entities are having equal priority and nobody is given a higher authority than the other. Now, dependency. Okay. Since we have a client server architecture and every request comes from the client, and we know that all the requests are getting solved and serviced by the server, we know how does the dependency act here. The clients are always dependent on the server. So a breach or any problem with respect to the server, okay, any problem with respect to the server can affect the entire client server architecture. Now, when you're talking about peer-to-peer networks, more or less like a distributed system here, So the clients are not dependent on a central server wherein it has the information distributed over all the machines. I mean all the client machines. Yes, Siddhant. Good afternoon and welcome to the class. We have been dealing with computer networks today. Okay. So next what we're going to see is we're going to see about the performance. Okay. Now how does each of the architecture perform? Now when you're talking about a client server architecture, the server can be upgraded to more powerful, to be made more powerful, to cope with the demand. Okay. So if you want to increase the performance of the client server architecture, what you really need to take care of here is upgrading your server machine. Now, upgrading the server machine would naturally bring in a performance, increase in the performance level in the client server architecture. But when you're considering the peer-to-peer network, actually, if any of the machine in the network gets slower, what happens? The entire network gets affected, and hence when you're talking about the performance, the performance of the entire networks gets affected here. Is the idea clear? So when you're talking about a client server architecture and when you're talking about the performance, what you need to take care of is definitely is a server machine, and if you need to increase the performance, okay, so the server has to be upgraded. See, you can scale in your network by adding more devices. But if you're adding more devices, the network should be able to accommodate it. Now, what do you mean by the terminology? The network should be able to accommodate it. Definitely, the server should be able to accommodate it, right? Only if the server is able to accommodate it can we say that the performance can be increased or the network can grow. Okay, so just a minute. But in a peer-to-peer network, if the machines in the network is slow, so it is not just one machine, but any of the machines, not entirely, I'm sorry, here not talking about the entire machines in the network, but even though if one of the machine performs lesser, what happens? The entire network gets affected. Now let me take about a class as an example. So we are talking about the marks of a class or the grade of a class on a whole. So how would we say the pass percentage of this batch, right? This is how we address. So even if a student does not perform well, the pass percentage of the entire batch gets affected. But what if all the students get good marks? Definitely the pass percentage is going to be a wonderful percentage, right? So similar is a case of a peer-to-peer network. Okay. But when you're talking about a client-server architecture, see, a class with 10 students, a class with 20 students, and a class with 50 students, and think about the same educator who's going to teach, or the same teacher that who's going to teach you. Now, this particular educator should be trained enough to look after all the students, to understand the different understanding levels of all the students and then teach accordingly. Only then the class would be more effective, or can you say that the result performance can be brought to a better level? Is the idea clear? So the server can be upgraded to be more powerful to cope up with the demand. Okay. Now, if the machines in the network are slow, we say that the entire network now gets affected. Now, about backup. See, in the client server architecture, naturally the server has a role, right? A role higher to considering that of the client. So whatever there is in the client machine, and if you opt for a backup, definitely the backup would be there in the server machine. Okay. So something that you need to note here is the storage of the server machine or the main server is predominantly a larger one, and this is why the data gets backed up on the main server. right? Now, when you're talking about a peer-to-peer network, each computer has to be backed up, okay? Or each system has to be considered to have a backup information here. Is the idea clear? Now, only then the backup facility works here. But when you talk about a client server machine, it is just enough that the main server does all the backing up. So at a later point of time, whenever you want the data, you can get it access from the main server. Is the idea clear? But when you're talking about a peer-to-peer network, it is more or less like a standalone system, and in though it is connected. Okay. Now, in the standalone system, if you have not saved elsewhere, it is really difficult for you to get or retrieve the data once. While you lose the data or something. Is the idea clear? So this is how each of the points are maintained in the case of a client server or a peer-to-peer network here. Okay, what is it? We talked with respect to the security, and who would be taking control over the security? Definitely the server in the client server architecture. And in the peer-to-peer, you do not have a central control over the security. Each system should have security features enabled in it separately. Fine. When you're talking about the management, who does the management? Who manages the entire network? When you talk about client server architecture, definitely the server, which is having a higher level or higher priority when you compare to the other participating entities in the networks. And when you consider a peer-to-peer network, no central control over the network. Okay, there is no central control. Instead, the control looks like a distributed one wherein all the participating entity has some or the other role to be played here. Okay. Now, when we are talking about the dependencies, the clients are highly dependent on the server because as per the actions that what we saw right now is clients are always sending requests to the server which is getting serviced from the server here. Okay. And when you're talking about the peer-to-peer network, clients are not dependent on a central server. Okay. So next, when you're talking about the performance, when you're talking about the performance in a client server architecture, you need to definitely speak about the performance or upgrading of the server system. But when you are considering that of a peer-to-peer network, then the machines in the networks are slow. Then what happens? The entire network gets affected here. So you need to take care of each individual system in the peer-to-peer network. Is the idea clear? So this is how the performance is considered. And when you're talking about backup, now why is a backup required? Backup is required because you need to, what if the system crashes? Okay. What if one of the client machine gets destroyed, the connection gets lost? Now what happens? Definitely the server will have the backup of the information that is being stored in the server. In the client. Okay. So whenever there is a backup, you can retrieve the data at any later point of view. But when there is no feature of backup, actually it is like complete loss of data. Can you imagine a loss of data in the case of a banking section? Okay, in a banking sector wherein you have lakhs of amount deposited in your in your bank account, and you tend to say that there is no backup and the machine has collapsed. Now, in this case, we cannot afford to, right? So, in such cases, we need to think about backup, and definitely we need to think about such things in a client server architecture where the data is all backed up on the main server. Okay. So each computer has to be backed up separately when you are considering a peer-to-peer network. So moving on, now the different types of networks based on the communication channel. Okay. So based on the communication channel, now we already saw what exactly is a communication channel. Now, what is a communication channel? It is a medium via which the communication happens. Okay, and we also saw that the communication channel can be either wired or wireless. Okay. Now, the computer networks are formed when computers are connected with one another. So we see that only when there are nodes, we say that there is a network formed. When there are no nodes in the network, we say that there is no network formed, right? So what exactly is a computer network? They are formed when the computers are connected to one another. Now, the connections among the hosts are established using specific communication media. Okay. Now the connections among the hosts are established using specific communication media categorized as wired computer networks or wireless computer networks. Now this is a main classification based on the what on the basis of communication channel. Okay. Now let us see what exactly is wired and what is wireless. Okay. Okay, so let us see. Now, the host and the other devices are interconnected through wiring or cables. Okay, so in the wired computer networks, what happens? The host and the other devices are interconnected through wiring or cables. Now, the cables in the wired networks are twisted pair coaxial cable and the optical fiber, wherein yes, wherein we usually use the highest in demand at the present scenario is the optical fiber cable. Okay, now let's get to learning each one of them in detail. Now let's see what is a twisted pair cable. Okay, now the twisted pair cable would look like a braided format wherein you have the different wires running like this. Okay, and then you have okay. So something like that of how when we learn the DNA or how we braid the hair, right? So this is how the twisted pair cable would look like. It is actually a pair of insulated wires. Now, something that you need to notice, each of this wire, though you consider as a pair which is twisted, each of this wire is insulated. So it is not going to take any sort of noise from the outside environment. Now they are twisted together to improve the electromagnetic capability and to reduce noise from the outside source. So what is to be noted here? This twisted pair, it is a pair of insulated wires. Now they are, why are we bringing twisted? Why are we twisting it? We are twisting it together to improve the electromagnetic capability and what happens to reduce the noise from the outside world. Now we need to understand what exactly are the different types of noise. Okay. Now, is noise meaning just the sound that we make? No. It is actually a signal, but all the unwanted signals are called to be noise. Okay. So what is a noise? Noise is something that is unwanted signal. See, suppose I'm taking the class. Now, this is an online class here. Now, definitely, see, my understanding is that only my voice is hearing you. Though I have reduced all the background noises, you might be at some point be able to hear maybe the sound of the TV that is buzzing here, maybe the birds chirping outside, or maybe the buzzing of the automobiles or vehicles that is going. Okay, because my house is somewhat in the main roads, so definitely such noise could be heard. Now, are these wanted signals? No, the signal that I am giving you, I mean, the lecture that I am broadcasting is the one that is actually needed, right? So this is the wanted signal, and all the other signals are categorized to be unwanted signals. Now, when you're talking about noise, there are different types of disturbances or noise that you learn. Um, you call it as thermal noise. Okay. Then we call it as intermodulation noise. Okay. Then we have something called as impulse noise. Right. Then we have something called as crosstalk. Okay. Likewise, we have different types of noise. Now, when we are passing things via a conductor, okay, now what exactly is a conductor? Now, the conductor is something which conducts electricity or light or whatever, okay. Now, the conductor can conduct heat and electricity, right? Now, even if you're talking about a conductor, it is an element with definitely electrons in it. So, whenever a heat or a temperature comes to it, the electrons get agitated and it starts expanding. We know that a metal expands on applying heat, right? So similarly, when you're talking about a conductor, what happens? There is a thermal agitation of electrons due to the increase in the temperature. Now, in that case, a disturbance caused is called as thermal noise. Okay. Now, impulse noise, whenever you have a lightning or something, what happens? There is a sudden rise or a sudden spike in the noise, right? Now, such disturbances are called as impulse noise. When you're throwing a bomb, right, a sudden explosion, so that means it is disrupting the usually the normal environment and causing a very big volume, right? So in this case we talk about impulse noise. Now, crosstalk, I'm sure most of you have come across crosstalk when you are indulging in a telephonic conversation. See, when you're trying to communicate with a person, when you dial a number to reach out, you tend to hear conversations in another communication link. Now, this is what we call as crosstalk. Okay. Now, intermodulation may be because of some devices that is being working or that is functioning near your device. So, for this case, it is likely to bring in some disturbances in your communication, and hence intermodulation. There is changes in the modulation of your noise. Okay, so these are the things with respect to noise or the unwanted signal. Okay, so now let us consider. Okay, when you're talking about pair cables, it is a pair of insulated wires. Now, this insulated wires, because it doesn't want the strength of the signal to get decreased. Is the idea clear? It doesn't want the strength of the signal to be decreased. So, it is giving proper insulation. Now, the wires are twisted together. Now, what does it provide? It provides the electromagnetic capability and reduces the noise from the outside source. Okay, so just a moment. Now, when you're talking about coaxial cable, okay, so coax is what? It is a shorthanded form of coaxial cable. It consists of a solid wire core. Okay, the coaxial cable would have a solid wire core. Now, this is going to be surrounded by one or more wire shields. So, it would be something like this. Okay. Now here, this would be the conductor part, and wherein the signal would be passing through the conductor here. Fine. So it is via this conductor that the signal would be passing, and you would have more shields. Now, why are these shields? These shields would be plastic casing or insulators to protect the signal that is going to be transmitted via the conductor. Is the idea clear? And hence the coaxial cable. Now, this consists of a solid wire core surrounded by one or more wire shears and each separated by a plastic insulator. Now, when you're talking about I mean, see, when you're talking about the twisted pair cables, the twisted pair can also be shielded as well as unshielded. Based on that, you have categories which are called as STP, which gives the shielded twisted pair, and UTP, which is the unshielded twisted pair. Okay. Now, the shielding is also given as an extra, provision for saving or protecting your signal. Okay. Now, let us consider the fiber optic cable here. Now, fiber optic cable, as I told you, it is the most popular one that is being used here. It consists of a bundle of glass threads, each of which is capable of transmitting messages modulated onto light waves. So, what is going to be used here? It is a property of the light that is going to be used here in the case of fiber optic cable. Okay, we know that light is travels very much faster than any sources of energy, and it is this property that is going to be taken by the fiber optic cable for the transmission. Now, it would consist of a bundle of glass threads. Okay, now each of this glass thread is capable of holding or transmitting messages. Now, when you're considering the glass casing. Now imagine that this is a glass casing, and this is how the light is actually a ray, right? A source of energy which is actually a ray. Now whenever it hits a whenever there is an obstacle or a hindrance, now when it hits a glass surface, what happens? It reflects, right? Now it reflects and then moves on to fall onto the opposite side. Now the opposite side again is a glass surface. What will happen? Again the reflection happens and goes back, right? So this is how the reflection inside the glass surface happens. It is this property that is getting exploited in the case of fiber optic cable. Now, throughout the glass material or the glass thread, the light would be reflecting here and there and then falling off and to reach till the destination. So the property that is being used by the fiber optic cable is total internal reflection, or which is called as TIR. This is the most important property of fiber optic cable, and it is via this property that the messages are going to be sent or transmitted. Is the idea clear? Okay, now apart from that, you have one more thing to be noted here. See here, the bending of the light ray. Now, this is also one of the properties that would be considered in the case of fiber optic cable. Now, when you're considering this to be a more dense medium, and this is a lesser dense medium, we have the normal here, and then we have a light ray which is falling from a more denser medium to a less denser medium. Now what happens here? We have, this is how the ray of light falls, and this is how the angle of incidence happen. Okay, now the bending or the reflection of the light, how does it refract to the opposite side or to a lesser denser media? How does it travel? It actually depends on the angle of incidence, right? So we consider that if the angle of incidence is less than the critical angle, we say that process of refraction happens. When it is greater than, that is when the angle of incidence is greater than the critical angle, we say that the property of reflection happens with respect to the light ray. Now, this is something that we have already learnt in physics, right? So, it is this property of when to cause reflection is studied, which is a condition wherein you have the angle of incidence which is greater than the critical angle. So in that case, what would happen here? So this is how it would happen if you're having two mediums of two density, wherein a light ray is going to fall here and here. Imagine that the angle of incidence is greater than the critical angle. It is not going to refract and move outside to the opposite medium, but instead it will fall inside the medium itself, or it would be reflected back inside the medium, right? So it is this property, the angle of incidence which is falling. Yes, Shiv Prakash, good afternoon and welcome to my class. So it is this property that is to be taken, this which is exploited by the fiber optic cable. See, if you are trying to take, the Wi-Fi installation, if you're trying to take a broadband connection at your homes, now everywhere, service providers are using OFC, or the optical fiber cable. Okay. So this is the shorthand form where they use it. So these are the details with respect to twisted pair, coaxial and fiber optic cable. Though you needn't learn each one of them in detail, we need to know what exactly is total internal reflection and how the property has been used. This is why I just extended the description based on the property of the ray of light. Okay. Now, prior to learning all these things, what you need to understand is we are talking about the wired computer networks. And in the case of wired computer networks, the wiring, the cables in the wired networks are in either of the following. Yes. You have doubts with respect to the cables? Okay. So moving on. Now, let us now learn the different wireless computer networks. Now, wireless computer networks, as I told you, they are the unguided medium because you do not have a physical connectivity running from between the devices or the physical wire. These are not the guided medium. Instead, this is the unguided medium, right? So what it does is it transports the electromagnetic waves without using a physical conductor. You would not be having. Yes, this is the Unacademy lessons. I hope you have seen it once when you take up the class, right? See, sorry, the unguided medium wherein you do not have a physical conductor, like how we talked about the different wired medium. Which were the wired medium? Yes, the classes are in the Unacademy. May I know what is your concern? See, so other than the twisted pair cable or the coaxial cable or the fiber optic cables, now all the other things which do not come with the cable category, we talk about the wireless computer networks wherein we use the air or the atmosphere as the communication medium here. Okay. Now, how can the wireless transmission be done? Okay, so this is what we are going to consider here. Now, now I've listed in the figure itself the different types of waves that are helping you in the case of wireless transmission. So prior to that, yes. Now, what are the different waves here? We are going to consider the radio waves, microwaves, as well as the satellite communication. Now, all these categories are going to be treated underneath, coming under the wireless transmission. Even the Infrared is also going to be treated as a wireless transmission here. So when you're talking about microwaves, radio waves, and satellite microwaves, let me just draw the spectrum here. Okay, so this is something with respect to a small portion of your electromagnetic spectrum. And here I'm taking a range for around 3 kilohertz to around 900 terahertz. And everything that is coming above the 400 terahertz are considered to be the light waves. Okay. So what happens is from 3 kilohertz to 3 gigahertz, you within this range of the electromagnetic spectrum comes the radio waves as well as the microwaves. Okay. Now, so let us see each one of them. The microwaves are the high frequency waves that are used to transmit the data wirelessly over long distance. Okay. Now, when you're talking about the mobile phone calls, now this exactly are high frequency waves that are used to transmit data over longer distances, right? Yes, Shiv Prakash, what is your doubt? Okay, so when you're considering the microwaves, these are the high frequency wave that are used to transmit data wirelessly over longer distance. Okay, so you need when you're considering long distance transmissions. See, when you consider the mobile phone calls, you do not have a wired connection, but still you know that there is a connectivity from the center to the receiver, right? And this connectivity stays as long as the communication is there, or either one of the communicating parties end up the call, right? So till then, the connectivity gets extended. So microwaves are high frequency waves that are used to transmit the data wirelessly over longer distance. Okay. Now, when you consider radio waves, they are used to transmit radio and television programs. So, what exactly are radio waves? They are used to transmit the radio and television programs. Now, when you're talking about satellite microwave, they are used in the satellite communication. So, satellite microwave for the satellite communication, if you're using the satellite phones or maybe the satellite broadcast for films or something like that. In all these cases, you use satellite communication, and here is where you use the satellite microwave. Okay, so these are the things with respect to wireless communication. Now, as I told you, these are coming under the unguided medium, and in the unguided medium, you really need to understand how the signal travels from the source to the destination. You can either have the ground wave propagation or the sky propagation. In the ground wave propagation, we are talking about actually the microwaves or the radio waves, and those of higher frequency actually occur for the radio waves with the higher frequency actually occurs in the sky propagation also. But when we are talking about satellite communication, definitely we have the it actually takes into consideration of sky propagation also. Okay, because it is taking the atmosphere. You may have either things running from the earth and then reflecting back, and also from the satellites also. Okay. So this is how the different propagation modes would be considered when you consider microwaves, when you consider radio waves, and finally the satellite microwave. Okay. So now let us see each one of them in detail. We already saw them in detail. Now, the radio waves, now they can be classified on the basis of frequency and wavelength. Now, since they're classified based on the frequency and wavelength, this is how we get the different channels in the radio station. Okay, we say FM so and so and so and so. We give a different number wherein we tune in to see which frequency range our device can be tuned in to reach this channel. So this is how we get access to the different radio waves here. Okay, so moving on, let's see the different network devices and hardware. Okay, so just a second. The network interface card, which is the first hardware. See, whenever we are talking about a network, it is not just the participating entities like computing devices, but apart from that, you need to understand that there are certain hardware devices also involved. Now, which exactly would or is helping you understand how the connections or communications between the devices happen. The first thing that we'll be learning here is NIC or the network interface card here, a device that is attached to each of the workstations and the server. Okay, now so this is a mandatory device. This is going to be inside any of the workstations and the server. Uh, just a second. Okay. What happens here is this device is attached to each of the workstations and the server. Now, what is the essentiality or what is the purpose of this hardware or devices? It helps the workstation establish all the important connection with the network. So, if you want a component or a computing device to be networked, if something mandatory is it should have the NIC card in it. Only then it can be involved into or connected to a network. Is the idea clear? So a device that is attached to each of the workstations and server. Which is a device? The device is a card, and this helps the workstation to establish all the important connections with the network. Now, what are the other names that are given to the NIC are TAP, I'm sorry, TAP or Terminal Access Point, and then you have the NIU, which is called as the Network Interface Unit, the acronym for Network Interface Unit. Now, these are the two names associated with the network interface card. Now, every NIC would have a unique physical address. Okay, and this physical address is called as the MAC address or the Medium Access Control Address. Now, if you ask me who gives the MAC address, it is actually the manufacturer that provides this address for the device. Is the idea clear? Now, this is a physical address. Now, the address would usually be of the hexadecimal format. Now, now this address would be unique. Okay, each device would have a unique address to it. Okay, and this address is provided by the manufacturer, and this is called as the MAC address. Now, wherein in a smaller network, maybe the device is getting identified using the MAC address, but when you're talking about an internet, in the internet, never the devices are identified using the MAC address. Instead, they are addressed using the logical address, which is the IP address, okay, or the Internet Protocol address here. Now, as I told you, the MAC address would look like a hexadecimal format. Now I can illustrate the same with one in your textbook. See here, it is given. Sorry, this is actually a colon. Okay, 2E colon FC, and see here 1 2 3 4 5 6. It has around 6 octets, and in each octet the value is in the hexadecimal format. Now, since it is having such a big combination, you can say that every time it's generated, you have a unique format here. And hence, this is how the MAC address is unique. Okay. Now, this is going to be just used for identifying the device, and it cannot be identified in a network actually using the MAC address. To identify it in a network, we actually take the help of the IP address or the logical address. Okay. So moving on to next is the Wi-Fi card. Now, what is this card? Wi-Fi meaning wireless fidelity. Okay. Now, this card, it is an internal or external LAN adapter. Do you call by the name card? It is actually the adapter. Now, what this does is this will help in bringing a built-in wireless radio or antenna. Now, why? For what reason? Now, when it brings a wireless system for the antenna or the radio, now this would allow to set up the workstation. Now, this is the case of a single node or a single computing device. So, whenever you're having a Wi-Fi card, so without considering the availability of a network access, it can you get access to the network facility. So this is the enhanceability of Wi-Fi card. Do not confuse it with NIC card. Only if you have the NIC card in the motherboard can your system be involved in a network. Okay. Now, next we're going to see the different devices. Okay, the different devices that would help you in the process of networking. Now, if you ask me why, because see, whenever a signal is getting transmitted over time and over distance, there is a chance that the intensity of the signal or the amplitude of the signal gets reduced. Okay. Now, there is a lot of difference between me pronouncing the word see this loudly and if I'm trying to speak very softly. And when I'm trying to speak very softly, do you think the intensity matters, right? So similarly, what happens is over course of distance or over course of time, actually the signal tends to degrade the intensity. Now, in such cases, you need to transmit the signal with the same amplitude regenerated. Likewise, so many works are involved. Now, for such reasons, you also use something called as networking devices in your network. Now, we're going to see a few networking device here. Okay. The first one that we're going to see is a hub. So this is a networking device. As I told you, it has multiple ports. Now, why multiple ports? Now, in each port, you can connect a device here. Now, the device can be the participating entities in your network. Okay. So they are used for connecting multiple computers or segments of a LAN together. Is the idea clear? So a hub is nothing but a networking device. This would help to connect, has multiple ports and they are used for connecting multiple computers or segments of a LAN together. Now the hub can be both active as well as passive. Now what an active hub does is it will electrically amplify the signal. As I told you, the intensity or the amplitude of the signals can go low. Okay. Now, what active hub does is, whenever it senses that the amplitude of the signal is going low, what it does is it will try to amplify the signal as it moves from one connected device to another. So this is something like a repeater. Now, why the repeater does? It is repeating the original signal with the same amplitude and with the same characteristics, right? But when you're talking about a passive hub, it is nothing. It is just allowing you to pass the signal, and it is not intelligent enough to understand whether the signal amplification is going low or going high, and it would just pass. Passive means it is very passive in the sense it will only act what it is being designated to do. Okay, what exactly is it designated to do? Just the passing of the signal from one device to another. Okay. So next is a switch. Okay. Now switch exactly is a device which uses the manufacturing address. We learned something called as MAC address, right? So switch is a device which uses the MAC address for addressing. Okay. Now let us see. It is again a networking device. It is used to segment networks into different subnetworks. Okay. So whenever you want to divide a big network into different small parts or subnetworks, these subnetworks are called as subnet. Okay, shorthanded form or truncated form of subnetworks. Now, switch is a device which comes to help you. Okay. Now, when you divide it into subnets, what the advantage is that you can have more devices and more addressing space. Is the idea clear? Now, you will get to learn only that when you know what is subnetting and when you learn IP addresses in detail. But as the syllabus is not demanding so, what you need to understand is a switch is just a networking device, and the purpose of this networking device is it segments networks into different subnetworks, or which is called as a subnet. Okay. Now, when you're segmenting the network into smaller subnet, what happens? Prevents the traffic overloading in a network. So, you can prevent the traffic overloading in a network if you're segmenting the network into smaller subnets. And what is the other functionality of the switch? See, it helps in filtering. Now, filtering means it transforming data in a specific way and forwarding it to the packet. Now, what does a funnel does? We know that when you're trying to pour impure water through the funnel, and if you have a filter paper, what does it do? The filter paper actually absorbs all the impurities and just let the liquid flow through the funnel, right? Similarly, what the switch does is it does the responsibility of filtering. That is, it is actually here, it is actually removing all the unwanted data, and whatever you are requiring, that particular data is getting transformed in a specific way for forwarding the packets. Is the idea clear? So this is how a switch or a networking device named switch will work. Now next is bridge. Now what exactly is the little meaning of the word bridge? You're connecting two places. Bridge is always constructed, usually constructed over across a river, right? So it would be connecting the two banks, right? So similarly, here also, bridge is a device, networking device, which is helping you to link two separate networks together, two networks together. But something that you need to note here is both the networks have to follow the same protocol. Is the idea clear? So bridge, though it is connecting two networks, what you need to take care of or what you need to understand is they can handle networks that follow the same protocol. Okay. Now the smart devices that knows which computer are on which side of the bridge, so allow those messages that need to cross the bridge. So one more thing, like what we told about hub. There was a active version of the hub, right? So similarly, when you're talking about bridge, there is these are smart devices. Why? As I told you, you would have two different banks, but note the point, both the bank are following the same protocols. Now, whenever a communication or a message passing has to be done, the smart devices, what it does is it would know which computers are on which side of the bridge, and it is likewise the communication is or the message is being redirected or sent to the destination. Is the idea clear? So since it knows whether it wants to cross the bridge or be in the bridge only for passing the messages. So moving on, yes, this is the most important this is the most important of the networking device that we need to learn. The device is the router. Now, what is a router? It is a network device that forwards data from one network to another. Now, then, what would be the difference between, what would be the difference between a bridge and a router? Now, see here, a router can handle different protocols. So, usage of a different protocol is immaterial when you consider the networking device router. So, the working is exactly like bridge. The only difference is it can handle heterogeneous protocol and not homogeneous protocol. So, a router uses logical addresses. Okay, now this is one more thing that you need to consider, the logical address in the sense the IP address is used here, whereas the bridge and switches uses the physical or MAC address. Okay. Now this is yet another difference when we consider a router as well as a bridge. A router takes the help of logical addresses while the bridge takes the help of physical addresses or the MAC address. Okay. So moving on to the next device, which is the gateway. Let me take a break. So next is the networking device is a gateway. Okay. So a gateway is more or less like a router plus the extra functionalities added to it. So a gateway is a network device that connects dissimilar networks. Okay. So again, this is something to be considered. As I told you, it holds more or less the properties of a router, right? So it connects dissimilar networks. Now it establishes a intelligent connection between the local network and yes, between a local network and external networks with completely different structures. Okay, so it establishes intelligent connection between the local network and external. So whenever you have a local network running and you're trying to communicate with a dissimilar network that is outside, okay, which is your external network. So in such a case, you use the networking device gateway, which gives in or brings in an intelligent connection between the two networks. So as I told you, it is more or less like a router. Okay. Now the extra functionalities that the gateway would take is it acts as a proxy server as well as a firewall. Okay. So whenever a router acts as a gateway, these are the two functionalities that is to be embedded inside the gateway. That is, it should act as a proxy server, that is a machine which appears to be a server though it is not a server. Okay, now what firewall does? Firewall is the one who prevents the unauthorized access. Now why fearing unauthorized access? Because there are chances of discrepancies of viruses onto your network. Okay, so only when you consider when you have installed firewall. Firewall is actually a software, a system designed to prevent the unauthorized access to or from a private network. Okay, so these are the details with respect to a gateway. Now next, to conclude our session, we are having two more things to learn, which is the cloud as well as the IoT. Okay, cloud is nothing but the internet-based computing. Actually, the internet today is using the cloud. Now, wherein you can have the sharing of the resources, software and information. Okay, but on demand. So only whenever it is demanded is being it provided to you. So it is being held somewhere, um, somewhere away from the system, and it is a common pool wherein you can use it. Sometimes the cloud comes paid, only then you can use it. Otherwise, there are free versions also, but with restrictions. Now, cloud computing is the use of internet for the task you perform on your computer for storage, retrieval, and access. Now, you're not you do not want to learn them in detail, but just a know-how of how the cloud is. Now, wherein you have different categories like private cloud, public cloud, okay, based on the different strategies and restrictions that they provide. And to end with, let us learn IoT now, which is the emerging technology, and it is a talk of the town today, which is Internet of Things. Okay, now it is a technology wherein you can connect, in fact, every devices, not only your computing devices, almost every devices concerned with you, and making your environment very smart. Okay, now these connections are via the help of internet or the wide area network, and the connections can be either wired or wireless. Now it is simply like saying that I'm sitting in this room, and I feel that it is really hot and I want to switch on the AC. I can do it via my I can use it via my mobile phone. Or imagine I'm stepping out of my office, moving on to my home. So prior to entering the room, I can make the environment very cool in the home by remote access of my air conditioner from my office and setting to a very cool temperature. Okay. Now, how are such things made possible? Definitely, it is via using the IoT or Internet of Things. Now, this is how you have made your air conditioner smart. Is the idea clear? So this is how you make your devices smart. Now IoT allows people and things to be connected anytime, any place with anything and anyone using any network or any service. Now this is the extendability of something we call by the name IoT or Internet of Things. Apart from that, we have something also called as IoE, Internet of Everything. More or less, both are the same. As I told you, IoT, it allows the people and things to be connected anytime, any place, anywhere, anyone. Now, there is no restriction. You need to use this particular thing or this particular service. Okay, in the case of IoT. Okay. So the devices that form the IoT, you can have all your home appliances, the wearables, the vehicles, the factories, agriculture for smart farming. Okay, you can make the vehicles also smart, right? Now for all these places, you can use the technology IoT. Okay. To summarize, these are the contents that we came across or we learned today. We had an introduction to computer networking, advantages and disadvantages of networks, and then components of a computer network, the types of the different network, and also the different network devices. Okay, so these are the things that we covered in today's chapter. It was a very lengthy session as it was a marathon session, and I know it's really hard for you to sit along and learn for such long duration. But please do go through the lecture at least part by part so that you get to learn all the topics in detail. Now, before winding up, let me remind you of both the iconic and plus subscription of Unacademy and my promo code SLYT, which would fetch you in getting a 10% discount in the Unacademy subscription if you wish to avail to. In the beginning of the presentation, I have already introduced the different schemes and for the CBSE students also, the iconic as well as the plus subscription. Now, based on your choice, you can take up a subscription and you can avail for that. Now, all you need to do is you need a smartphone wherein you have to download the Unacademy Learning app. And upon using my Promo code SLYT. This can fetch you around 10% discount in the Unacademy subscription. So with this note, I'm winding up today's session, hoping to meet you all in the coming classes also. So thank you all for joining.